so dealing with our significance tests, we're going to go into talking about type 1 and type 2 errors. So with this, let's start with a type 1 error. So our type 1 error right here is the null hypothesis is true, but we make the wrong decision. So whether that wrong decision was done by miscalculation, whatever the case may be, the type 1 error is the null hypothesis is true, we make the wrong decision. Okay? Now, with that, your significance level, in other words, we've been dealing with that 5% significance level, or our 0.05, right? In other words, our 5%. In other words, we're saying that a type 1 error will occur by chance by that amount. So in other words, if you're dealing with a 5% significance level, then 5% of the time, you're probably going to end up with a type 1 error. That's what it's referring to. Okay? So the smaller significance level, the less type 1 errors you will have. So the better data overall things will turn out to be. The next type of error we have is a type 2 error. In which case, on the type 2 here, the alternative hypothesis is true, but we make the wrong decision. So in other words, we pick to say that the null is our correct answer. However, the alternative was to be the true answer altogether. So again, these are just switching back and forth between which one you're picking, okay? But the big thing is as far as which one is true. So for a type 2 error, this is saying that the alternative hypothesis, your HA, your HA, your alternative hypothesis is true, but you made the wrong decision. Again, that could be due to calculation error, data fed to you improperly, things of that type would cause these type of errors. So the easiest way to think about this, and definitely when taking a test or doing a type of homework problems, dealing with type 1 and type 2 errors, is make a little box like down here at the bottom. In which case, you can simply label on your x-axis here at the top right here, we can say our null hypothesis is true and our alternative hypothesis is true. And then we can say over here on the y-axis set up on the left-hand side, at the top we can say we reject the null hypothesis, and then on the bottom we say we fail to reject the null hypothesis. Okay? So, in which case, you can see that if you were to take our type 1 error, so the null hypothesis is true, but we make the wrong decision. So in other words, we say the null hypothesis is true right here, however, we reject the null hypothesis. So as we say we don't want the null hypothesis, we're picking to say that the alternative, right? Well, in that case, that's when we have a type 1 error. Okay, so the null hypothesis is true, however, we reject it. So that gives the type 1 error. And for a type 2 error, the alternative hypothesis is true, but we make the wrong decision. So in other words, we fail to reject the null, right? So in this case, for our HA to be true, our alternative hypothesis to be true, so our hypothesis is true, but we make the wrong decision. So we fail to reject the null hypothesis. In other words, we're accepting the null hypothesis. In other words, we're rejecting the alternative. That's what the fail to reject the null. That is a way that AP Statistics and College Board and everything else has just kind of put it into play. And I've seen it in multiple books dealing for statistics and AP Statistics. They want to write it as fail to reject the null hypothesis. In other words, they're saying you accept the null hypothesis, okay? So that gives us, if we fail to reject the null hypothesis and we know that the HA is true, that's going to give us a type 2 error. Now, of course, these other ones make sense for the good decisions if you go forward with that, right? If you look at the alternative hypothesis true, and yet you reject the null, so in other words, you're accepting, that gives you a good decision, so you're good. As well as if the null is true and you fail to reject the null, you're accepting the null, then that makes a good decision. So again, sometimes it takes a little bit of time just getting used to the wording on this and reading it out loud to really grasp the understanding of what it's saying there. So definitely take your time, read slowly with this, and grasp what it's talking about. And this may seem super simple, but a lot of people make mistakes just because the wording gets you confused. All right. So I'm going to show you a little example here from a book example explaining how to interpret and label the type 1 to type 2 errors. Alright, so let's watch that little video.
Hi, this is Jason Molesky. In this example, we'll take a look at type 1 to type 2 errors. Potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses, the null hypothesis that P equals 0.08 against the alternative hypothesis that P is greater than 0.08, where P is the actual proportion of potatoes with blemishes in a given truckload. For this problem, let's describe a type 1 and type 2 error in the setting and explain the consequences of each. Well, recall that a type 1 error occurs if we reject the null hypothesis when that null really is true. That would happen if the producer finds convincing evidence that the proportion of potatoes with blemishes is greater than 0.08, when in reality the actual proportion is 0.08 or even a bit less. As a consequence, the potato chip producer would send that truckload of acceptable potatoes away, which may result in lost revenue for the supplier. Furthermore, the producer will have to wait for another shipment of potatoes before producing the next batch of potato chips. Now also recall a type 2 error occurs if we fail to reject the null hypothesis when the alternative is actually true. So in this case, that would happen if the producer does not find convincing evidence that more than 8% of the potatoes in the shipment have blemishes, when that is actually the case. That is, we really have a bad batch of potatoes, but the sample we selected doesn't indicate that, or doesn't give evidence of it in this particular case. As a consequence, the producer uses the truckload of potatoes to make potato chips. More chips will be made with blemished potatoes, which may upset customers.
Alright, so as you can see, it's pretty straightforward on type 1 and type 2 error. Again, type 1, null hypothesis is true, but you make the wrong decision, and type 2 is the alternative hypothesis is true, but you make the wrong decision. The big thing with these two is a lot of the questions that I like to follow with that when you determine what type of error you have is thinking outside the box as far as how it really affects either, in that case, the manufacturing of the potato chips or the making of whatever type of product they're talking about or whatever is being delivered or served, whatever the case may be. So read into the question and think about it. Think outside the box. Don't just think about the numbers and what's this and what's that. When you actually describe the error, then think about how does that affect the real world as far as if it was to be in play, which in most cases those types of things do happen in real life. So that's the fun part about it, alright? So just think about it a little bit outside the box. Alright, so hope you learned a little bit of something and understand type 1 and type 2 errors, and I'll see you next time.